Hello everyone, I'd like to welcome you to this video titled Box Plots, and the goal for this video is for you to understand how you can use a box plot and measures of spread to describe a data set. Now you will need to turn to page 463 in your Go Math book, get out your math journal, pencil, and also calculator. Now the first question you may have is, what is a box plot, or what does it even look like? You can see here on the right of the screen, this is even described here as a box and whisker plot. You'll hear them being described that way as well. And what we have here is the box, and then you can see to the right, those are called, and to the left, those are called the whiskers. Okay, and you can see dots throughout that box and whisker plot that represents points of data within the set. Now, on page 463, you can see that there are 5 values for the data set that are shown in a box plot. So the first one is the least value. The second one, we can see the lower quartile. Another one is the median, upper quartile, and also the greatest value. So some of those terms may be a little tricky. Least value, not too difficult. That's just the least valued number. Lower quartile, what that is, that's the median. We know what a median is the median of the lower half of the data, and we'll talk about how to find that throughout the video. The median is another value of the whole entire data set. Upper quartile, median of the upper half of the data, and also the greatest value, which is the greatest number. Now, what we're going to do, and we'll do this together, is there's a question on page 464, and we have a set of data here, and we're going to make a box plot out of this data set. So we can see the question on 464, number 2, says the daily high temperatures for some days last month are shown. Make a box plot of the data. So whenever you are making a box plot of the data, the first thing that you'll need to do is order the data from least to greatest. So I would like for you to pause the video now and order the data from least to greatest, just like I have right up here on my screen. Now that we've done that, we're going to start making a box plot. So first of these, and remember there are 5 different values that are part of a box plot. Okay, so the first thing is the least value. Very simple. Okay, so the least value is 75. All right, and I can see that these are intervals of 2, so I'm going to make my first dot is right here for 75. Not too difficult there. Now, my next dot, so I have my least value already figured out. My next dot is the lower quartile, which means that's the median of the lower half of the data. Now, how do I find the lower half of the data? What I can see here is I have 12 different numbers in my data set. So what I do is I just find the first 6 numbers, 1, 2, 3, 4, 5, 6, and I need to find the median of these numbers. Okay, so I have my median here. This is going to be my lower quartile. All right, and then what I have here is 78 and 79. What I would do with that is I would add both of those together and divide by 2, and that's going to give me 78.5. So 78.5 would be considered my lower quartile. So in other words, it's the median of the lower half of the data. So I'm going to put my next point right here at 78.5. Now, the next one is the median. Now, that's the median of all the data. Okay, so what we can do now, I'm just going to erase this. I'm going to find the median of all the data. So what I do, I'll cross out to the left and then to the right and keep doing this until I have my median. And you can see I have 2 middle numbers. So again, I add both of those together, divide by 2, and that's going to give me 83.5. So I mark my spot right there at 83.5. So that's my median. My next step is I need to find my lower quartile. Now, what's the lower quartile? That's the median of the upper half of the data. So just like we found the lower quartile, with the first 6 numbers, I find my upper quartile with the second half of my numbers. So 1, 2, 3, 4, 5, 6. I can just block it off like this. I'm going to find the median of the upper half of my data. We can see we have 2 middle numbers here. Whenever we have 2 middle numbers, we add them together and then divide by 2. So 88.5 would be my upper quartile. So I'm going to plot my point right there. So that's the upper quartile, and I would like for you to do this with me. And then finally, the greatest value, which is not difficult. You just take a look at your data set, and that's the highest number that you have, and that is 94. So we'll put our point right here. So now what we have done is we have identified the 5 values for our box plot. Now the next step is connecting these dots, and understanding how you connect these dots is very important. So what you want to do is you want to take your least value and connect it to your lower quartile. And I'm going to use some different color of ink so we can really see our dots here. And then what we're going to do is we're going to make a box that connects our lower quartile, goes right through our median, all the way to our upper quartile. These lines should be straight if at all possible. And then what I'm going to do is I'm going to take my median, I'm going to draw a line right through it. You can see my median is right here, and it has a line right through it with my box. And then I take my upper quartile and I connect it to my greatest value. Okay, so this is the box part of the box plot. So what do these different dots mean? Or what do these different parts of my box plot mean? So again, we can see this is the least values, my first dot. Lower quartile, this is the median. Okay, so the median is within your box, but there's a line going through that dot representing that it's the median. We have the upper quartile, and then also we have the greatest value. So this is how you create a box plot from a set of data. Now we're going to look at the next part of this lesson on 464, and that's titled Finding the Interquartile Range. Now I know we're using a lot of different terms within this lesson, but just take it a term at a time. So what we have here, it says a measure of spread is a single number that describes the spread of a data set. One measure of spread is the interquartile range, or sometimes we call it the IQR. What that is that's the difference of the upper quartile and the lower quartile. So when we think about the data or the box plot that we just created, okay, we can see that my upper quartile was 88.5. My lower quartile was 78.5. All you do is subtract those two from each other and you get 10. So the IQR, or the interquartile range, would be 10. So it sounds like a really fancy word, which it kind of is, but it's not difficult to figure out. You just take the difference between the lower and upper quartile, and that is your interquartile range. So I'd like you to turn your Go Math books to page 465, and let's take a look at the problem that we're going through here. So it says the box plots compare the weekly earnings of two groups of salespeople from different clothing stores. Find and compare the IQRs of the box plots. So a couple things that you need to understand whenever you're reading a box plot. First of all, you need to be able to look at the number line and see the different intervals within the number line, because if we think that it's just an interval of 1 or whatever it may be, we're going to be really off. So we see this number line with a different weekly that represents the weekly earnings. So we see 1,000, 1,500, and 2,000. So what we can see here is from 1,000, we have 1, 2, 3, 4, 5 sections until we get to 1,500. So that means the intervals are 100. So that's a really important part of being able to understand how to read a box plot. Look at the intervals on the number line first of all. Also remember the different parts of a box plot. What do they represent? So we can see that first dot represents the least value. The second point represents the lower quartile. That third point represents the median. And then we have the upper quartile. And then we have the greatest value. So you can see all those different parts are part of the box plot. So they're asking us to find and compare the IQRs of the box plot. So what we have here, for the first one, we can see that group A, this number represents $1,100. So that's the lower quartile. And then group A, the upper quartile, we can see represents $1,800. So what we do is we take those two values and we subtract them. We find the difference. Okay, so we can see $700 for group A is the IQR. Now let's look at group B. We can see that the lower quartile for group B is $1,400. The upper quartile, you can see, is 1,850. Subtract those two. The IQR is $450. So now that we have both IQRs, remember interquartile range, what we can see here, and I want you to write this down on page 465, is that group A's IQR is greater. So the salaries in the middle 50% for group A are more spread out than those for group B. So that's what an interquartile range will show you. They take a look at what it will do is it'll take a look at the middle 50% of the data set, and it'll show you how consistent or how spread out the data is within your data set. Now what I would like you to do is turn to page 466, and we are going to work on numbers 1 through 7 on page 466. So the problem reads, the RBIs runs batted in for 15 players from the 2010 Seattle Mariners baseball team are shown. Then it says use this data set for numbers 1 through 7. Now the first thing that you need to do is order the data from least to greatest. So let's do that first. So now that we have all of our data ordered from least to greatest, we can start working on our box plot. Now I know the book has it a little bit different here, but what I like to do is I like to just go through my box plot in these steps that I have here on the right, so I don't get too mixed up with everything. So I always find my least value first, which is number 4, which is the number 4, I should say. And what I'm going to do is I'm going to just put my dot right there above my 4. Now it says the lower quartile. What the lower quartile is, that's the median of the lower half of the data within my set. Now, since I have 15 numbers, okay, what I will not include is the median. all right, within my set of numbers. So since I have 15 numbers, what I'm going to do is I'm going to take my first 7 numbers, 1, 2, 3, 4, 5, 6, 7, and then for my upper quartile, I'm going to take my top 7 numbers, 1, 2, 3, 4, 5, 6, 7, and I will leave my median out. Okay, so my first 7 numbers here. So I'm going to find the median of these first 7 numbers, which is 13. So that is my lower quartile. And I know I skipped a step for number 3, but I just like to do this in a certain order. Now we're going to find the median. Okay, so the median of my whole data set here, what I'll be able to see is going to be 29. I'm just going to keep marking off from left to right, and I'll be able to see that 29 is my median. So again, when you have an odd amount of numbers, you're going to have a clear-cut median. You don't have to add numbers together and divide by 2 or anything. So 29 is my median. So again, since I have a median, I do not include that number with my upper or lower quartile. So to find my upper quartile, and I should be plotting these on here. My apologies. Let's do that together. So 13, the median is 29, and then upper quartile, let's find that together. That's going to be 43. So let's plot that on our line as well. Upper quartile here. And then we need to find our greatest number right here, which is 64, and make our point there. Now from here, what we need to do is create our box plot, or some people call it a box and whisker plot. So what we do is we connect our least value to our lower quartile, just like that. And then what we do is we make a box connecting my lower quartile and my upper quartile, just like that. And then we draw a line through our median, and then we connect our upper quartile to our greatest value. Try to do that as straight as you can. So that is our box plot. Again, least value, lower quartile, median, upper quartile, and greatest value. Now, in order to find the IQR, what we need to do is we find the difference between the upper and lower quartiles. And here we have 43 as our upper quartile, 13 is the lower quartile, so not too difficult there. That's going to be 30. And then the range, even though we did not discuss this, we talked about this in previous videos, is the difference between the least and greatest value. So we have 64 is our greatest, 4 is our least. So our range we can see would be 60. And again, that's how you create a box plot. So this concludes the video on box plots. If you have any questions about this concept, please come and see me.